Okay, so looking at one of the homework problems, we have find the function given below, or not find, for the function given below, find a formula for the Riemann sum obtaining by dividing the interval a, b into n equal subintervals and using the right-hand endpoint for c sub k. Then take the limit of the sum as n goes to infinity to calculate the area under AB. Okay, so we want to figure out what the width of our rectangle is going to be. I don't want my pen to be big. And so we can find delta x, the width of our triangle. This is equal to our length, 0 minus a -1, all over n rectangles. So this is going to be 1 over n. We need to look at what is f of, let me see, we need to find our c sub k value. It's our right endpoint, so that is a plus 1 over n times k. But a in our case is -1 plus k over n. So we want to look at what is f of c sub k, or f of -1 plus k over n. So plugging this in wherever we see an x. So we have 3 all times -1 plus k over n, quantity squared, plus 3 all times -1 plus k over n, quantity cubed. So our summation, S sub n, this is equal to k equals 1 to n of f of c sub k. Notice we can factor out a 3 there from both of those terms. And actually I can pull that 3 outside of my integral, or not my integral, my summation. It's just going to make my life. Can we do that? Yeah. Of -1 plus k over n quantity squared plus -1 plus k over n quantity cubed. That's our f of c sub k times delta x, which is 1 over n. One over n, that doesn't have a k in it, so I technically can pull that outside of my summation formula. So this is going to be 3 divided by n, the summation from k equals 1 to n. And I'm going to need to do some side work on distributing this. So let's look at -1 plus k over n quantity squared. So I'm going to have to look at -1 plus k over n times -1 plus k over n. So if I distribute this out, this is +1. -1 times -1 is +1. This is going to give me a negative k over n minus another k over n plus k over n times k over n is k squared over n squared. Or it is 1 minus 2k over n plus k squared over n squared. So that was just that first piece. So 1 minus 2k over n plus k squared over n squared. plus, I need to know what that is, quantity cubed. So -1 plus k over n, quantity cubed. I could take what I got for the square, 1 minus 2k over n plus k squared over n squared. And multiply that by -1 plus k over n. So I need to distribute that out. Give myself more room. Okay, so that would give me -1. That's going to give me plus a k over n. Now distributing -2k over n. So negative and a negative, so plus 2k over n squared. No, I distributed. Sorry, that's -2k over n times -1. That's a plus 2k over n. Negative 2k over n times positive k over n. So that's a minus 2k squared over n squared. Now distribute that k squared over n squared. So k squared over n squared times -1 is negative k squared over n squared. And k squared over n squared times k over n. So that's positive k cubed over n cubed. And combining like terms. Do we have any like terms? Let's just rewrite it descending order of power. So k cubed over n cubed. We have a k over n plus a 2k over n. That's a 3k over n. We have a negative 2k squared over n squared minus a 2k squared over n squared is minus 3k squared over n squared. N squared. And then we also have this -1. Plus k cubed over n cubed plus 3k over n minus 3k squared over n squared minus 1. I really technically don't need those parentheses. So I think I can combine a little more like terms. Notice that 1 minus a 1, those go away. I have a positive k cubed over n cubed. Let's look at our squares. We have a k squared over n squared minus a 3k squared over n squared. That's a minus 2k squared over n squared. I have a negative 2k over n plus a 3k over n. So that's plus a 1k over n. Are there any other terms? I don't think so. I probably should have stopped before I did all that and wrote, because that first question asked, what is S sub n? And so I'm not sure, but I would probably write it before I distribute it and stuff. Let me just pause and plug that in and see. Okay, so you started, I just factored out an n on the denominator here to make this an n squared. And when I pulled out the 1 over n, I have the same thing, except I have 1 less n in the denominator. And now I'm going to use my formulas. So I would have all times, I'm going to have n squared in the denominator. Let's just say 1 over n squared, times the summation of k cubed. And that's the same as n all times n plus 1 all over 2 quantity squared. So that's just the k cubed minus 2n. Now let's look at the k squared piece. So summation of k squared, that's going to be n all times n plus 1 all times 2n plus 1 all over 6 plus k. So the summation of k, that is n all times n plus 1 all over 2. I think I can clean some of this up. So this is 1 over n squared. If I square each piece in here, this is going to be an n squared all over n plus 1 quantity squared all over 2 squared, which is 4. I notice right here, one of my n's cancels. And technically over here, my n squared cancels. So that's going to give me, and over here, 2 goes into 6 3 times. That's going to give us what? N plus 1 all times 2n plus 1 all over 3. Plus, I'm going to have to distribute anyway, so let's just do it. N squared plus n all over 2. So we still want to distribute out and maybe cancel if we can. 3 over n squared. This is going to give us n plus 1 times n plus 1. So that's n squared plus 2n plus 1 all over 4 minus, if I FOIL this out, that gives us 2n squared plus n plus 2n. So that's plus a 3n plus 1 all over 3 plus n squared all over n plus n all over 2. So I'm just making sure I can technically get a common denominator and combine like terms then. So my common denominator looks like it's going to be 12. So 3 over n squared. So if we multiply this by 3 over 3, that's going to give us 3n squared plus 6n plus 3. Everything's going to be over 12. Let's multiply the second term in the bracket by 4 over 4. And let's distribute that negative 4. So that's going to give us minus 8n squared minus 12n minus 4. And then this one, let's multiply by 6 over 6. So that gives us plus 6n squared plus 6n. Which we can combine like terms. And notice this 3 and this 12 over here, they actually, because it's strictly multiplication, we can simplify. So 3 goes into itself once, and it goes in here 4 times. So we actually have 1 over n over here. And then, so we have a 3n squared minus an 8n squared plus a 6n squared. So that's -5, that's positive n squared. I have a 6n minus a 12n plus a 6n. So all n's cancel. And I have a 3 minus a 4. That's a -1. All over 4. Darn it. So I didn't bring down, this should have been a square, 1 over n squared. And so technically this is the same thing as n squared minus 1 all over 4n squared. So that's the summation piece. That's the S of n, and then we're going to look at that as n goes to infinity. And so the last piece is looking at the limit of this as n goes to infinity. And notice that when we do that, we get infinity over infinity. And so we're going to use our rule that we could divide each term by 1 over n squared. We're multiplying by a fancy one. And so when we do that, this is equal to the limit as n goes to infinity of 1 minus 1 over n squared all over 4. And so as n goes to infinity, 1 over infinity goes to 0. And this is going to give us back just 1 over 4. So if we summed up an infinite number of rectangles underneath that curve from -1 to 0, we would get back 1/4.